All right, what we're going to do is look at derivative rules for trig functions and some relationships that they have. Some of them are really tricky, some of them are really easy. All of them you'll need to memorize. And you'll use them so much that they should stick in your brain anyway. It shouldn't be too tough to be able to do all this. But first, let's go ahead and look at the derivative of the sine, but let's look at the limit rule. So we're going to take that whole limit rule where we would let let's see, we don't want that guy, we want this guy. The limit as h approaches 0 of f of x plus h minus f of x all over h. Now, we're not going to have to do this every time, but I just want to use it this once to show us what's going on here. And so if we're looking with the sine of x, then what we're going to do is we're going to look at the sine of x plus h and the sine of x. Those are my two functions that I'm going to be working with. So how is this going to shape up? Well, we're going to look at the limit as h approaches 0 of sine of x plus h minus the sine of x all over h. And remember, we're wanting to find a place where we can get the h in the numerator and the denominator to divide out, or where we can rewrite this in a way that allows us to use that h. But right now, if I substitute in a 0 everywhere, I get 0 in the denominator, and that's not going to work. So you might remember a trig function, sine of an angle plus an angle, the sum and difference stuff. And so we can actually rewrite the sine of h as the sine of a, let's see, sine x cosine h plus cosine x sine h. And then we're going to finish that off with a minus sine x. Okay. All this is over h. Well, I still have that h in the denominator that I can't get rid of. So I have to think of a way that maybe I can do that. Well, check this out. What we're going to do is we're going to take these two guys right here and this guy right here. And the cool trick that I'm going to do is I'm going to factor a sine x out of that. So we're going to have the limit as h approaches 0. And just I'm factoring out of only the green. So I'm going to have sine x times cosine h minus 1 minus cosine x sine h all over h. Okay, you with me on that? And then what I'm going to do is break this up into, oops, this should be a plus. I'm going to break this up into two pieces, because with that addition symbol in here, I actually can work with sine x cosine h minus 1 over h, and I can work with cosine x sine h over h, and I can do a plus, and I can work with each one of these guys independently now. Okay, so so this gets it quite a bit more manageable because now I've got little small chunks to work with. And so let's just carry this on right up here. If you'll look on that very first guy, I can actually take the sine of h and put him in the front, and that just leaves me, or the sine of x and put him in the front. That just leaves me with cosine h's in the middle. Same with this guy. I can take him and put him in the front. And so what I end up with is sine x times the limit as h approaches 0 of cosine h minus 1 over h plus cosine x times the limit of sine h over h. Running out of room. Sine h over h. Okay. All right, not a big deal. Not a big deal. The cool thing is this. We can actually look now at some limit rules that are going on here on your calculator. So if you graph and look at your calculator, this guy right here, cosine of h minus 1 over h. If you graph that guy and look at what's happening as h approaches 0, the function actually has a limit of 0. So this will be sine x times 0 plus. And then we've talked previously about the graph of this guy as he goes to 0, sine h over h. As h goes to 0, that guy is just a 1. So we're going to end up with cosine x times 1. And sine x's go away. And so the derivative, based on our limit, is cosine x. So this is kind of a long drawn out process. I probably am not going to ask you to do it again. But really important is to be able to understand that when I have the graph of something, I can look at that and determine what the limit is. And then I can use it to help me figure out other things. So in the long run, the important part is this guy right here. The derivative of the sine of x is cosine x. All right, so here are some derivative rules that you need to make sure that you have written down that involve the different trig functions. So sine x, cosine x we saw. The derivative of the cosine x is negative sine x, and the derivative of the tangent of x is secant squared x. So you will use those three quite a bit and probably have them committed to memory fairly quickly just through your work. The other three are the cosecant of x, and the derivative of that is negative cosecant x cotan x, the derivative of the secant of x, which is secant x tan x, and the derivative of the cotangent x, which is negative cosecant squared x. Those are a little bit trickier to get sorted out in the brain at times. So just work with these guys, practice these guys, have them written down so that you can see what's going on. And before you know it, you'll have them memorized, okay? So how can we use these things? Well, let's work out a couple of examples. First off, we've got x squared times sine x. This is a classic product rule problem. And so what we need to look at is we need to look at this guy as a u and a v. So when I look at this guy, I need the derivative of u, which is 2x, and I need the derivative of v. So the derivative of sine x, I just look up here, the derivative of sine x is cosine x. So when I solve this problem out, I'm going to take the first function times the derivative of the second. So y prime is equal to the first function times the derivative of the second, plus the second function times the derivative of the first. So when you put all of this together for one problem and an answer, the derivative is just going to be y prime equals x squared cosine x plus 2x sine x. And there's really not much else we can do with that. We're done. We're done there. Okay. I'm going to move this quotient rule guy up. So let me just grab him and move him up real quick. We'll work him up here. We've got a little bit more room. So I'm going to go with low d high. So u prime is equal to low D high, well, derivative of cosine. Look over here, derivative of cosine, negative sign. Minus high, D low, well, derivative of 1 is 0. Derivative of sine is cosine. So negative cosine x. All over 1 minus sine x squared. Okay, so this looks really crazy. What do we got? Well, on top I have 1 plus sine x squared, sine squared x, plus cosine squared x. Actually, that shouldn't be a 1, that should be a minus sine x. Let me just give myself room here. All right, looks like this. And if you'll remember back to the glory days of trig, we loved anything that showed up as cosine squared x plus sine squared x, because that whole thing goes to 1. And so what I'm really working with is 1 minus sine x over 1 minus sine x squared. And if I have the same thing on the top and the bottom of a fraction, I can cancel it out. So 1 minus sine x cancels one of those guys out. And my overall derivative then becomes 1 over 1 minus sine x. You will need to pay attention to some of your trig rules. You'll need to use some trig identities on occasion, but a lot of these problems will simplify down a little bit with just a little bit of effort and a little bit of algebra.